Oh, fancy meeting you here at the Daily Space Weather Show. Thanks for joining us here at the Smash News Network, least busted name in news. These are 24-hour videos of the closest star. That's the house favorite wavelength. Don't know what it is? Ask in the comments. If you know, you know. Please note setting sunspot 3576 in the southwestern limb, which is your lower right, and the massive filament to its east, which is left of that massive sunspot 3576 that we're saying farewell to in this night's video. There's a little closer view of that. Sunspot AR3576, one of the most interesting sunspots of solar sunspot cycle 25 so far. Give it time. There's plenty for a lot more action. Here's a great view of that filament also that is east of the sunspot. That could lead to a indeed massive solar flare and CME, coronal mass ejection, when the sun blasts material out of its atmosphere, or corona. Anyway, let's take a brief look at Earth. Sakurajima has been erupting. It indeed produced some St. Elmo's fire, as oppositely charged particles rub against each other and make lightning close to the caldera. Some explosive activity there at Japan. Sakurajima, yeah. So these are the rest of the volcanoes that are erupting: Subanose-jima, Ibu, Semeru, Merapi, Dakono, Popocatépetl, Fuego, and Sabancaya. We'll also cover earthquakes, and it looks like we have a continued earthquake risk for the western portion of the North American plate. The North American Pacific Plate boundary, folks, is showing signs of seismic unrest. Remember, any earthquake can be a foreshock, even a big one, so pay attention to this one. It's a 5.0 in the Gulf of California. What do you think of that? A 5.0 in the Gulf of California could be a foreshock. There's the location. It was early this morning at 6:38 Universal Time on February 15th. And before that, we had a 5.1 at the Kermadec Islands and a 5.2 at the Pacific Antarctic Ridge. So unrest all around the southern portion of the Pacific Plate. Also, Tonga had a 5.0. Chad had a 5.0. That 5.0 magnitude earthquake wasn't made in the USA at all. It was made in Chad. Japan had a 5.0. That was only like 9 minutes before the 5.1 at Mexico, so both sides of the Pacific there, only a few minutes apart. Also, Southeastern Indian Ridge had a 5.0, so lots of places where we could be seeing foreshocks here, folks. Let me reiterate, any earthquake can be a foreshock. There's also a 5.0 at Peru, so that's quite a few earthquakes there, and we haven't had a big, really damaging one in quite a while. So statistically speaking, seems to make it more likely, according to me. And let's take a brief look here at some more SDO imagery. This is 1600 angstroms, and just a brief thing to say here about cosmology. So I don't know if you're familiar with the fact that in cosmology, everything to the right of helium on the periodic table is considered to be a metal. So lithium and everything else besides hydrogen and helium are considered to be metals in cosmology. So what are we looking at here? We're looking at ionized carbon. You see all that carbon around the surface of the sun there, especially around sunspot 3576. You see all that white? Those are areas that are extremely rich in carbon. So of course not the sunspot itself, but the area around it. Lots of carbon there. And the point is, folks, you don't need supernovae to create metals. The heavy elements can be made right there in plain view Right there in plain view, there's ionized carbon right there on the closest star. So just let that one sink in. I know it might seem a little bit of a radical thing to say. Oh my God, dear God, heavy metals can be made like in plain view on the surfaces of stars? Yes, nuclear fusion and fission are occurring in those areas. So it is a rich chemical soup, the solar corona. And I'll just leave it there and not get too much more controversial in this video. After all, it is the daily space weather. So let's take a look at some stats here, starting out with the 10.7 centimeter radio flux, which is at 180, 178. I think it's at 178. I'm not really too concerned with it. 178, I think, is the radio flux right now. There's the 1 year chart represented by the black line, is the radio flux. Red line is the sunspot number. And yeah, 178 is the radio flux. There's the Space Weather Enthusiast dashboard, and we've got calm conditions here. No new CMEs on the way. So the ones from the past few days, they didn't show up really at all. There was basically no signal. I mean, it was kind of weird, but what can you say? Sometimes you fail your forecasts. Next, the Geospace Magnetosphere movie. That's the past 4 hours of Earth's magnetic moment from space. So yeah, it's calm. It's geomagnetically calm, and it's not very exciting for space weather. I mean, we still do have a very high likelihood of X-class solar flares, though. We'll explain why in a moment. Here's Earth's magnetic moment from the ground in the meantime. Yeah, the last 4 hours there. And again, things quite calm indeed. Yep, so that's what's going on from Earth's magnetism perspective, and geomagnetism currently at KP 2.67. KP 2.67 is the current state of affairs. And yeah, that's what's going on. So as far as the solar wind goes, it's calm. Less than 400 kilometers a second at ACE. Almost 500 kilometers per second at the Discover. So once again, a great disparity between the two different spacecraft there. So the Discover, a lot faster solar wind there, and also more dense. So at Discover, we're showing like 4.5 protons per cubic centimeter at nearly 500 kilometers per second. So looks like looks actually like a coronal hole high-speed stream too, interestingly enough. So yeah, check it out. It's where am I? Oh my God, I'm in the Milky Way galaxy. So yeah, this looks like a weak coronal hole high-speed stream here. If you look at it, you see this little uptick in the density, and the density dips, and then the velocity starts coming up. And then we've got a kind of a solid signal here in the plasma temperature as well as the velocity reaches its maximum point. So it looks a lot like a coronal hole high-speed stream, despite there not being very many well-defined coronal holes, which we will get to in just a moment. Next, the GOES magnetometers, and yeah, pretty smooth there. No surprise, no big space weather events. And next, of course, we'll have to check out the ever-popular top view ecliptic plane field plot. What is happening? What? Where am I? Oh, I'm in the constellation Cygnus. Okay, that's perfect. So there you go. There's our top view ecliptic plane field plot, and North Pole sector continues. Yep, it's looking quite indecisive in that eastern limb. So look at that sector boundary crossing, waving back and forth to the east and west. And those plus signs there on either side of the Earth, those are stereo A and stereo B. Stereo B on the left, which would be east of Earth, and stereo A on the right, which is supposed to be stereo ahead, but it's actually stereo behind now because it's seeing older space weather, and I'm not going to get into that, but that's what's going on. So here's our line of sight field plot, and yeah, that's a fantastic 4-day snapshot of all of the sun's observable magnetic fields. Not half bad from the National Solar Observatory. And here is the line of sight coronal hole plot. Not half bad, in fact, quite good. Quite good indeed. So we'll look at coronal holes next at SDO. There we are. 211 angstroms is the optimal wavelength through which to view coronal holes. And it looks like there is quite a bit of activity going on the far side there. Just not really on the Earth side in the past couple of days. So next we'll look at sunspots. Sunspots, they're kind of important, right? I know there are people claiming that there aren't sunspots, but guess what? We've got nearly 150 of them. Current sunspot number at, what is that, 143, 140, I'll say 143. Sunspot number 143. Here's our synoptic map by Spencer, who's very meticulous about not hand drawing things. Very nice. Everything is typed so neatly. Shout out to Spencer. And yeah, likelihood of X-class solar flare still 15%. I mean, I think it's a little bit higher from 3576. Maybe Spencer doesn't take into consideration the proximity to the limb. But in any case, I would say this area right here is an X-class solar flare watch. So I won't get into the mechanics of that either because we don't want the video to be too lengthy. This is, after all, the daily space weather. Here's our flare probability monitor and scoreboard, and that's what's going on. Again, most likely place for a large flare is in the southwest, but there's also a chance in the northeast because I see some activity popping off north and east of sunspot 3586. But we won't worry about that too much either. Here is our SDO magnetogram for the past 24 hours. And things looking pretty stable there. Let's switch to the continuum. So it looks like we're seeing some more sunspots forming up there in the northeast. So that was a forecast from a couple days ago. I looked at the magnetic fields and I said, hey, that looks like an area that is destined for more sunspots. And I think we see that happening now. So if that's a new method by which to forecast sunspot formation, that's kind of serious. Also, we have some new spots forming right around here, right near the equator here in the west, right there. Just south of the equator there, at least 3 new umbrae showed up. So looks like a little uptick in sunspot number here is possible, even though 3576 is setting. So our last views of 3576, possibly, although it might make it all the way around. There you go, there's a close-up, and let's just zoom all the way in. Say goodbye to sunspot 3576. I suspect it will make its way all the way around for a full Carrington rotation and rise in like, what is it, 17 days, something like that. Keep in mind the equator of the sun does orbit a little bit faster than the polar region, so this one's at a pretty high latitude there, quite far from the equator. Anyway, let's get back to some space weather stats, such as the GOES proton flux here returning to baseline levels. Most of the radio blackouts are largely turning into brownouts now. So radio communications are being restored at the south polar region. GOES X-ray flux there, only 1 M-class flare in the past 24 hours. Let's take a look at it from SDO. All right, here is that's the 131 angstroms wavelength. And there was a decent flare there up in the northeast. But I think that flare was from 3576, that M-class event. That looks like a more significant event. And of course, it is possible for multiple places to have a flare at the same time, which makes it a little bit tough to tell where the flare came from. But there's our close-up of 3576, a sunspot that we've featured a crazy number of videos on. Check out our shorts if you want a lot of short clips of the evolution of sunspot 3576. It was featured a lot. youtube.com/smashomash/shorts. They have been, shall we say, rather popular. So anyway, moving along to our star chart and so on, and our astronomy photo of the day. So here is our star chart. That's what's going on over our heads here at Lehigh Valley, Pennsylvania. If you want to make your own, try skyandtelescope.org. The moon and Jupiter up there high on the ecliptic. Next, our solar system forecast. First, where things are today. So there's where things are. And it's a lonely side of the solar system, folks. No planets over here except for Earth, although Mercury and Venus will be returning shortly. Here's where things will be in a week on the 22nd of February. And our astronomy photo of the day is some galaxy that's called the Sculptor Galaxy, also known as the Silver Dollar Galaxy, I believe. And it's got some pretty cool dust lanes. You can see a lot of absorption features there, shown by these dark streaks in here. I also see some likely dust lanes here that are perpendicular to the galactic plane, which is something that we often see. It has to do with the outputs of the stars, which tend to be very active and rowdy stars at the center of galaxies. You know, there are probably some giant blue stars that are orbiting this galactic core at insane speeds, and of course, there is a tendency for emissions to be sort of perpendicular to the galactic core, or to the ecliptic plane, I'll say. So that's and we also see a lot of blue there in the outer portions, an indication that the outer arms of the galaxy feature a lot of really hot, active blue giant type stars. So there you go. NGC 253 is the apod.nasa.gov astronomy photo of the day. Moving right along to CMEs, coronal mass ejections. Those are kind of important, I guess, and there's a massive one from today. Sup with that. So one out of the southwest, one out of the southeast, and then one out of the south. Are any of those earthly directed? Well, we'll find out, and then we'll tell you all about it. Let's take a look at the LASCOs next, and let's allow the C3 to catch up. So there's that CME from about 10 o'clock this morning. Oh man, they're not synced right. All right, well, we'll just have to deal with that. We do have more synced imagery though, so don't worry. Let's let that play through. Multiple things going on there. So this one out of the south may have an earthly directed component. Let's take a little closer look. There it is at its origin. And I definitely didn't notice that one earlier. So let's look at stereo A as well. And do we have it? Yes, it is there on stereo A. Nice. All right, so unfortunately the difference imagery isn't there, but the raw coronagraph is. So, well, it could be earthly directed. All right, fingers crossed. Fingers crossed, folks. Do we see motions on the Earth side of the disk? And the answer is, I don't think so. Here we've zoomed in one more step closer. Yeah, that's a far side event, folks. That's this. You can see some motions up here associated with that. You know, a lot of times when there is a large flare or a large CME, you see ripples going across the surface of the sun. And I suspect that's what's going on there. This is probably some sort of a little related thing. But there was a massive CME on the far side, it certainly looks like. We don't really see any evidence of that on the Earth side. So not earthly directed, folks. You will see a little bit of action up here around when that occurred. But yeah, no big plasma motions on the Earth side of the disk. That is a far side CME. And by the way, there's one kicking off as we make the video, which we are going to cover as well. Let's get to filaments. There's a pretty good view. And this filament down here, you know, this one here is, well, maybe it's some kind of a Buddhist filament. I don't know. You can see the way it's turning to the left there. So I don't know. It's actually like, almost like a lightning bolt maybe. Lightning bolt filament? I don't know. Just saying. So, yeah, that's what's going on the past 24 hours. And here are filaments. Starting out with the Cerro Tololo. The Cerro Tololo, Chile, ground-based observatory. And there is a massive CME happening right up here. There's a huge filament rising, and there's a crazy-looking active region there behind the northeastern limb. So that's a forecast for the next couple of days there. There's some serious action going on back here. And we'll show it to you here in a moment because it's already starting to pop off. Looks like there's a huge CME in progress as we produce the video. So yeah, you can see a ton of filaments here on the Earth side of the disk as well. Check it out. Let's do a quick count here. So that's 1, that's 2, 3, 4, 5, 6, 7, 8, 9. At least 9 filaments. I mean, there's certainly one there and one there. So that's at least 11. You could maybe say 12. So like a dozen Earth-facing filaments right now. It's a very good time to see large CMEs. So check it out. This is what's going on in the northeastern limb right now. And that is some serious CME action. So, seeing some stuff kicking off here as we make the video. That's just the past couple of hours from the Ghost 16 SUVI. That should make for some fantastic content in tomorrow's video. Like, right at the beginning of the video, we'll see that CME kicking off on tomorrow's daily space weather. So anyway, that's what's going on for the past couple of hours. Not half bad. Let's get the bonus features. Charging hazards are first. We ain't got none. Electron flux is next. It's still kind of low. There's the last year of electron flux, and you can see there's been an ongoing, a bit of an electron shortage at the F layer of the ionosphere, where the GOES 16 and GOES 18 measure the greater than 2 mega electron volt electron fluence. There's the forecast model, and it looks like NOAA's expecting a downtick. There is a coronal hole high-speed stream, so I don't disagree with that. Next, the ionosphere. There it is, the vibrational frequency of it. And no major space weather events going on, so no major anomalies happening in the ionosphere. Here's the anomalygram, and again, things are quite, what's the right word? Things are quite nominal when it comes to the ionosphere. By the way, if you want to follow filaments and name them after living people, do it over on Twitter, x.com/smashomash. Follow the hashtag #NameThatFilament. And we've been naming them after living people and having fantastic results when we name them strategically, like the Tamitha Scove filament from, what was that? Was that was in February of 2023, I think? The strongest geomagnetic storm of the entire solar cycle. We named that filament Tamitha Scove. So just Just a coincidence. It was an educated guess, folks. An educated guess. It was intentional. And it launched only a couple hours after I named it. Hashtag name that filament. Name filaments after your friends or your foes, or even yourself. There is the WHAM, the whole atmosphere model. And here's a careless whisper as we close the video out. There are the magnetogram and the SDO continuum. It is freaking awesome. Let's switch to meteorology. See that? You see that, folks? Do you see that right there? I hope that you better see that. That right there is the rainiest place in the world. The rainiest place in the world. How rainy is it, you ask? Well, it's rained 3 1/4 inches in the past 3 hours. So 1 inch an hour plus for 3 hours is pretty rainy. It is just an isolated area, though, folks. Just an isolated area somewhere out by, like, what is that, Tonga or something? Tonga? Something. It's a thing at a place where a dude is like, hey, it's raining. That's the rainiest place in the world, folks. The rainiest place in the world. And shout out to Eugene the philosopher. Hey, Eugene, when you're studying what's going on in the atmosphere, one of the things you can do is look for the rainiest places. Those are going to be very, very diffuse portions of the atmosphere. Of course, if you look at pressure, that's a thing too. Right? Mean sea level pressure. Those are the you could say the least massive portions of the atmosphere, right? Okay, never mind. I'm not going to get into crazy meteorological physics here at the moment. Let's just move on and show the regularly scheduled meteorology segment. You know, the world's wind patterns. There you go. The eastern world's surface winds shown here, jet streams shown here, jet streams for Europe, Africa, and the Middle East here. Huge jet stream bend just south of just over South Africa, actually. Surface winds of the central world shown here. Surface winds of the west. Jet streams of the west. We'll get to some forecasts here in a minute. And our satellite imagery is down. The GOES satellite is not returning data. So let's take a look at windy.com next. Yeah, windy.com. They got a great mobile app. If you've never checked it out, you could download it for free. Windy.com, folks. Now, we don't usually show the pressure isobars, but we do have them in here. A pressure isobar, for those of you who don't know, this is just an area of continuous pressure. So that's 1,020 hectopascals, I believe it is. Hectopascals are the units, I think. Hectopascals are what windy.com uses. And yeah, so that's precipitation type and pressure isobar. So there is a bit of a low there over Denver. We've got a mixture of precipitation types here. Looks like some warmer air on the tailing end. So Pennsylvania's got some snow that's going to be turning to rain as it moves across the state. That's, once again, pressure isobars and precipitation type. Next, our weather.gov map there is the key. Get your weather warnings yourself, as there are way too many counties for us to cover on this short video. Here are some forecasts. First, the GFS pressure and precipitation for the next 72 hours, that is. 72-hour GFS accumulated positive snow depth change in inches is next. Temperature anomaly in degrees Celsius is next. And next on to lightning. And it's been pretty calm on the west side. Here's a real-time lightning map from lightningmaps.org. Lots of lightning here in the eastern Mediterranean once again. Lots of lightning in there. And a little bit of lightning over the northern Atlantic. Closing things out with Doppler, because we ain't got no satellite maps. Look at that. The site can't be reached. Dear God, the site is down. Oh my God. So we'll just show the lower 48 and close this mother out. And remember, folks, in the year of the dragon, never try to sneak up on one in his own lair. That is a terrible mistake. And this is a terrible success. Thanks for tuning into the Smash News Network, least busted name in news. We're delighted to have you. And until tomorrow, may that solar wind be at your back. While I go back to the bunker again, climbing all down here and eating MREs. Oh.